Welcome back to the Foundations of Math. Today we're going to go over Cartesian products and how to find them. So, right off the bat, we have two sets here. We have set A, whose contents contain 4 and E. These are the elements. And set B, who has the elements 2 and C. And we're being asked to find the Cartesian product between A and B and A squared, and then finally the cardinality of A, or the size of A. Anytime you see these flat lines next to a set, it just means the size. And we actually have a definition of the Cartesian product right here. So the definition of the Cartesian product is all of the ordered pairs from sets A and B. Now, visually, I think it makes a little bit more sense. I'm more of a visual guy myself, so I'm just going to jump into the first example and kind of show it that way. So the first one we're asked to find is the Cartesian product of A and B. So, as I said, it's a set in itself, so you're going to want these curly braces. And now you'll see A and B, where A is an element. That E, if you haven't seen that before, that means A is an element of set A, and then the small b is an element of set B. So the first element of set A is this 4 here. So I'm just going to draw this bracket. So this is 4. And then the first element of set B is a 2. So our very first ordered pair of our Cartesian product is the first element of each set. Next, it is every single combination. So we're going to go 4 again. But this time, we're going to do the second element of set B, which is a C. So this is the ordered pair 4C. And then again, you'll kind of notice a pattern. It's going to be E. So the second element of set A, 2. And then again, the second element of set A, and then the second element of set B, which is EC. And that's it. That's our Cartesian product of A and B together. So again, going over this definition, it is every element where each of these ordered pairs, or elements of the ordered pair, belongs to the original sets. And when I say ordered pair, that just means the pair here. So let's say 4 and 2, and the order matters. So this 4 and 2 is distinct from 2, 4, and you'll see that in a second here. So let's do our next example. I don't know why that did that. The Cartesian product of B and A. And I'm going to go a little bit faster this time just because it's the same process. But now our B is in front. So our first element of the ordered pair is now going to be all of the elements of our second set B. So this is actually going to be 2, 4. And you'll see right away this is why that order matters. And you'll see here that basically they're kind of the inverse, like this E2, 2E, 4, 2, 2, 4. But these are not the same. These are distinct Cartesian products. Next, we're going to go over A squared, which can be rewritten as A cross A, or the Cartesian product of A itself, which, if you want, you can write out A again, but it'll be 4 comma E cross 4 comma E. So again, you'll take the first product of each set, you'll take the element of each set, and then it's kind of the same process. After you get the hang of it, it's very, it's a lot of manual work. It's just doing the same thing over and over. And the next thing here is that cardinality of A. So it's the size of our set A, which right now it's just the number of elements in A. So our size of A is 2 because we have a 4 here and an E here. Sorry, I don't know why I did curly braces. It's just, it's not a set. It's just a number. So the size of A is 2. So let's go over a slightly different but a little bit more complicated example. Okay, now we're given the set A is A and B, and then the set B is 1, 2, and 3. Now, before we had 2 and 2, so the addition of the third element here shouldn't make too much of a difference. It'll just be a little bit more writing, but it shouldn't be too bad. So we're being asked to find now a cross B, the Cartesian product of A and B, the size or cardinality of the Cartesian product of A and B. We're asked to find the Cartesian product of A and the empty set. So if you haven't seen this symbol before, this means the empty set. So I can actually write that right here. I'll just write this up here. So if you ever see that symbol, let me write a little bit better. This is the set of no elements. So this is actually these curly braces with nothing inside. And then we're asked to find the Cartesian product of A in the empty set and then the size of A in the empty set. So let's jump right in. So we're being asked to find the Cartesian product. I keep saying cross product. The Cartesian product of A and B. And again, it's the exact same process as before. We're going to be finding ordered pairs, and we're going to be taking the first element and then each of the others, and then the second element of each of the others. And with the magic of editing, okay, and that's it. So remember that A1, A2, A3, and then B1, B2, B3. Again, if this was B and A, it would be different ordered pairs. So just be sure to double check which order is which. Next, we're being asked to find the size, but we're being asked to find the size of the final product. So we just have to count the elements. So remember that each element isn't the individual, so it's not the A and the 1, the A and the 2, the A and the 3. It's actually the ordered pair, which is the element within this set. So this is all one element. That's one. That's one. So it's actually 6. So let me write this. And there's actually a really handy formula. If you like to memorize formulas, all it is it is the size of set A multiplied by the size of set B, which equals the size of set A is 2, and the size of set B is 3, which just equals 6. And we can verify it visually. We see we have 6 elements here as well. If you have a much larger set, let's say you have 10 elements in A and 10 elements in B, and you don't want to write it all out, you can just do 10 times 10 equals 100, instead of 2 times 3 equals 6. Now, we're going to do the Cartesian product of A. Oh, that's a bad X. And the empty set. So let's look at what that would actually be. So we are looking for ordered pairs A and B. So that would be A, but then there's no element in the empty set. So there's no ordered pair we can actually create with that. So A times the empty set is just the empty set itself, or you can still just write the empty braces if you want to get a little practice. Mine are still pretty bad. And then we want to find the size of A in the empty set. So let me write that. Or the cardinality. Either word works. And using the formula, the size of A is 2, and the size of the empty set is 0, which just equals 0, which we can verify visually up there. So we've gone over some of the more common problems you might find with Cartesian products. So let's go over a few more niche examples. So given A is just an element 2, and B is actually the element of the empty set. So this is the empty set within a set. So this is actually not just the empty set. This is an element of 1. So the cardinality of B would actually be 1. We are being asked to find A cross, or the Cartesian product of A times A and A. So this is not, let me just write this kind of a little bit more. So what we can do is have B be a set itself. So B doesn't need to be, so when I say B here, I'm talking about the Cartesian product of A and B in this definition. So this B doesn't need to just be a number or a letter. It can actually be a set itself. So let's break this down into two steps. Let's just do the Cartesian product of A and A, which is just itself. And again, if you want to verify the cardinality of A cross A, or sorry, the Cartesian product of A and A should be 1 because 1 times 1 is 1. Now, if we want to find the Cartesian product of A and itself, and I know I'm saying the letter A a lot and Cartesian product a lot, all I'm saying is the set of all ordered pairs that are possible to be made. So right now there was only 1 for A and A. For 2, we're just taking that original set 2 and we're finding the Cartesian product of that and of this ordered pair, which is just 2. Sorry, I forgot the bracket. 2, 2, 2. And if we were asked to find the cardinality of this, it would still be 1. So remember, it is the elements within the curly braces. So this is just one element. Even though it contains multiple numbers inside, ordered pair inside the ordered pair is just an element of 1. And then you'll see this B here is the set of the empty set. So this B can almost be written as an empty set within an empty set. So this actually has a cardinality, a size of 1, because there is one element within the set. And we're being asked to find A cross B. So let's do the Cartesian product of A and B, which we'll take the first. So that is a 2. And then it is actually the empty set itself. And you may be thinking, why is A the Cartesian product of A and the empty set and A and B, not just the empty set? And that is because this ordered pair is valid, because this is an element within the set. It is not just an elementless set. So this has no elements. This has one element. So just an important distinction. Okay, and for our final example, let's tie this back to something you've seen 1,000 times before probably, and it is the Cartesian plane. So this is our y-axis, and this is our x-axis, and we're being asked to plot the ordered pairs of the Cartesian product of A and B. So let's look at what A and B would be. So the Cartesian product of A and B, almost looks like not equal to. So the first element is 1 and 2. So there's no numbers labeled on here, so we're just going to do a rough estimate. But this is going to be our x, this is going to be our y. So if we were to plot it 1 in the x direction, let's say that would be here. And then we'll go up 2, so that's probably 1. That's probably 2. So that is going to be our ordered pair of 1 and 2. And this right away shows why 1 and 2 does not equal 2 and 1, because the ordered pair 2 and 1, as we'll see in a second, is going to be somewhere over here. So our next one is going to be 1 and 1. So we'll go 1 there, and 1, 1 will be somewhere around there. So I'm just going to write that there. It might get a little messy, but those are the points. Our next one is going to be 2, 1. And again, right away, we see that this is going to be 1, 2, and 2, 1 is going to fit in somewhere around there. So this is 2, 1. Oh, it's a little messy. Maybe I should here. I'm going to actually change these dots to red, just so it's clear. And then the next one, again, the last element is going to be 2. Oh, sorry, I made a slight mistake. It doesn't need to be. So remember, in a set, As long as the elements are there, it doesn't matter if I swapped this 2 and 1 with this 2, 2. So the fact I did 1, 2, 1, 1, 2, 1, 2, 2 isn't necessarily wrong. I just usually do it in that order because it makes sense for me, but this is still a perfectly valid set, even though I did the 2, 1, the last element of B, before I did the first element of B. So this 2, 2, I'm going to use the red just for continuity. So 1, 2, 1, 2 is going to be here. So we plotted the 4 points, and it actually makes a square. And that is how to plot on A and B. And you'll actually notice that the Cartesian plane is a number line and a number line, and we're plotting on that. And this can actually be written as the real numbers, the Cartesian product of the real numbers and the real numbers of itself. Just a fun little fact. Then yeah, that is Cartesian products in a nutshell. Hopefully these examples made things a lot easier. If you have any questions, definitely leave a comment below and then subscribe if it helped. Thanks.